In this video, we're talking about cyclic quadrilaterals. So first of all, a quadrilateral is a shape with four sides, kind of like a rectangle or a parallelogram or something. And a cyclic quadrilateral means you can draw it inside of a circle, just like this. So one really important thing about cyclic quadrilaterals are if you take two pairs of angles like across from each other, they add up to 180 degrees. All right, so a few corollaries. Basically, it's these two. So if you have a pair of angles that add up to 180, that means that it is a cyclic quadrilateral. Also, if you have a situation like this and alpha matches beta, then you also have a cyclic quadrilateral. This is pretty similar to that angles subtended by the same arc theorem that we saw before, where these two angles were equal to each other. All right, so let's do a couple questions. This one here, 22, and then we have x, and we know x plus 22 equals 180 as A, B, C, D is a cyclic quadrilateral. All right, great. So just take away 22 from both sides, really. So x equals 158 degrees. Done. Next one, find x. Similar situation, x plus 7 plus 3x should all equal 180. That means, well, if we simplify the left-hand side, we're going to get 4x plus 7. So 4x equals 173. Then it's really just a matter of dividing out by 4. So we take 173 and divide it by 4. You're going to get 43.25. Great. Question 3, is this a cyclic quadrilateral? Well, we look across 180. Great. Yep, adds up to 180. Fantastic. And then when we take 40 and 50, that makes us very sad. That adds up to 90. So the answer is no here. It's not a cyclic quadrilateral. Now this is a really weird shape because it's not even a quadrilateral at all. So normally in a quadrilateral, all the angles will all add up to 360. This is an impossible shape. All right. Next one, is this a cyclic quadrilateral? Well, the answer is yes, and that comes from that second corollary here. Those two angles match, so that's good to know. Cool, and that means you could draw a circle around it if you wanted to. Next one, ABCD is a parallelogram and a cyclic quadrilateral. What are all the angles in ABCD? So a parallelogram is a quadrilateral where the sides are parallel, just like that. And it's claiming to be a cyclic quadrilateral, which means that it should be kind of inscribed in a circle. Now that circle is really hard to draw, and you're about to see why. Okay, so I'm just going to get rid of that circle so we can see it pretty clearly. I'm just going to call this angle alpha, beta, gamma, and delta. There we go. So we'll be seeing lots of Greek letters when we deal with angles, and that's an example of that. Okay, so we already know alpha plus gamma is supposed to equal 180, and then also beta plus delta is also supposed to equal 180. Now, let's continue these lines out. So if we continue this parallel line off here and here, and then we continue this black one out here, well, you might actually remember a theorem about parallel lines that tells you that these two have to add up to 180. But if you can't remember that theorem, then you can have a think and go like, okay, well, these two bits look the same. So you've got this gamma here, and then this gamma up here. And that's another theorem about parallel lines. And then you know gamma plus delta equals 180. At any rate, you have to have gamma plus delta equals 180. Just due to the fact that these are all parallel lines. Similarly, you have to have alpha plus beta equals 180. So basically, if you have all four of these equations, the only way you can really make that work is everything being 90 degrees. So one way you could see that working is if you take two equations here. So if we label these equations. So I'm going to take 1 and 3. So that's going to be alpha plus gamma equals 180, and also delta plus gamma equals 180. And you're going to like subtract these equations from each other. So you're going to get alpha take delta equals 0. Therefore, alpha equals delta. Once you have alpha equals delta, it basically locks in everything else. So equals gamma equals beta, which all equal 90 degrees. So this special shape is a rectangle. Kind of a tricky proof, but it all relies on those parallel line theorems along with the opposite angles being adding to 180 in a cyclic quadrilateral.